So you may be wondering, why in the world would we why would we try to take things to 3 dimensions? Essentially, when we're dealing with 3 dimensions, what this allows us to deal with is to have 3 separate variables. In other words, 3 separate unknowns. So let's read through this example. A convenience store sells 23 sodas in a summer afternoon in 3 different sized cups. The summer volume, or the total volume, was a certain amount. The prices were certain amounts, and the total sales was a certain amount. So we have, some various bits and pieces of information. How many of each did the store sell? We're trying to figure out how many 12 ounce, how many 16 ounce, and how many 20 ounce cups this particular store sold. When we don't have, we kind of have to reconstruct this. So the first question we're going to ask ourselves here is, what sort of variables should we be using, and what is each of their meanings? Well, what are we looking for? We're looking for the number of 12 ounce cups the store sold, the number of 16 ounce, and the number of 20 ounce cups. So those are going to be the 3 different things, the 3 different variables. So X is going to represent the number of 12 ounce. So this is the number of 12 ounce. Y is going to represent the number of 16 ounce. Whatever. And Z is the number of 20 ounce. So I'm being very specific here with what these variables mean. Whenever you decide what a variable means, you need to be specific. If you just said X is 12 ounce cups, then when you look at that, if X is 12 ounce cups, is that the number of cups that are sold? Or maybe it was the price that they sold for, or the total price that you gained from them, or the total amount of liquid that they held. And it's a very bad idea for you to have something that's ambiguous like that. You need to know exactly what your variable means. So the number of 12 ounce cups, the number of 16 ounce cups, the number of 20 ounce cups, these are very unambiguous, and so that's why they make good, and they're also the things we're looking for directly, so that's why they make good variables here. So to put this question into, to be able to solve this, what we need to do now is we need to rewrite each of the individual statements in this question as equations. Each of the statements is its own equation. So first off, I'm going to take this statement here. The total number of sodas sold was 23. Well, let me ask you this. If you had 2 of the first type, so this is a hypothetical. If you had 2 of the first type, 3 of the second, and 4 of the third type of cups sold, how would you find the total number of cups sold? You just add them up, right? This would be, what, 9 cups? Of course, that's not what's going on here. We didn't just sell 9 cups. We sold 23 cups. And we also don't know how many each of these are individually, but this is where the variables come in handy. We know that X is the number of the first type, Y is the number of the second type, and Z is the number of the third type. And if I just sum them up, just like I did with the 2, the 3, and the whatever else it was, we get X plus Y plus Z equals 23. This is our first equation, and this equation literally says the same thing as the total number of sodas sold was 23, as long as I had my X, Y, and Z defined in this way. Alright, the total volume of soda sold was 376 ounces. Well, this is going to represent, this second equation is going to just describe the total volume. The total volume is 376. Something is 376, so something equals that. We just need to figure out a way to figure out the total volume sold. Well, if I know each 12 ounce cup has 12 ounces in it, I know that's an assumption on my part, but I'm comfortable with it. Each 12 ounce cup has 12 ounces of fluid in it. I'm going to say 12 times X is the total number of ounces of fluid, of soda, I guess in this case, that was sold. 16 times the number of 16 ounce cups, so 16Y, and 20Z. Let me scoot this over. So that's my second equation. You notice everything in this equation is talking about the volume of soda. So 12 times X, this is 12 ounces of soda per cup times the number of cups. 16 ounces of soda per cup times the number of cups. This is an amount of soda, We add those together, we get an amount of soda. It's necessary. I'm spending an awful lot of time on this because this process is very important for when we get into later questions. We're going to be doing a lot of questions like this in this class. The total sales for the soda was $28.45. So this third equation is going to be referring to the total number of sales. And, well, conveniently we know, or we were given, the how much each of these different types of cups was sold for. The 12-ounce cups are sold for $1 each, so the total dollar value we get from them is 1 times X. The 16-ounce cups sell for $1.25 each, so 1.25Y. And the last one, 1.4Z. And in total, this should be 28.45. So you can see we have 3 equations. And conveniently enough, actually, it happens quite frequently, they're all in standard form already. So that means we can go ahead and write up the system of equations. 1, 1, 1, 23. That's my first equation. 1x plus 1y plus 1z equals 23. 12, 16, 20, 376, and 1, 1.25, 1.4, 28.45. And we'll plug this into the calculator. I'll be right back as soon as I finish plugging it in. Alright, let's see, I'll go ahead and run RREF again. However, let's say it's been a little while since I've run it. Let me clear this off. Maybe I'm starting up and not doing this for a while. I'll just remind you where this is at. It's over in Math, and we'll scroll down to RREF. That's the one we want. I want to run it on matrix A. So in the Names tab here, I have A selected, and I press Enter. Close that up, and we get... Looks like we have 1s along the diagonal and 0s elsewhere, so this actually is a fully solved matrix. We get 6, 9, 8 as the numbers we're interested in. So that means x equals 6, y equals 9, and z equals 8. In other words, 6, what is that, 12-ounce cups? 9 16-ounce, and 8 20-ounce. I believe the actual question here was to how many of each size did the store sell? Yep. And so there we go. This is how we're going to be doing several of these word problems. So if you didn't understand any of these steps, go back and rewatch it or ask questions.